Hello everyone, welcome back to another Geostats lecture video. And in this lecture video, I want to talk about another LISA, right? Another local indicator of spatial association, right? Our second one. And this is going to be the Getis Ord G, right? Our local Getis Ord. And just as always, I'm going to walk through the equation. I'm going to walk through what each term means. And then I'm going to talk about how we interpret it. And then I'm going to wrap up this entire section talking about the idea of multiple hypothesis testing, which is something that affects both Getis Ord and also local Moran's eye. Let's go ahead and jump into the equation. So our G for the ith polygon here, so this is G sub I instead of I sub I, is going to be equal to, and this is going to be a little bit more complicated than the local Moran's eye. So it's going to be the sum of J of the weights matrix of Ij times our Z sub J minus the average of Z times the sum of J times the weights matrix of Ij divided by the standard deviation of Z times the square root on the top is going to be n times the summation of J times the weights matrix squared minus the sum of the weights matrix squared over, that should go all the way down, over n minus 1. Okay. So what I want to point out here is we are basically taking the standard, so this standard deviation times what is more or less a standard deviation in a way of the weights matrix over, and up here we have the weight times the difference between the value and the mean of all of the neighbors, right? So let's go ahead and walk through what we have here. All right, so this is our target polygon. Right, anytime you see this J, right, just like before, right, this is the jth neighbor. Right, this is, again, a lot of these parts are going to look similar, so hopefully this is almost a review for you at this point in terms of what these different parts mean. Right, this Wij, anywhere we see that here, we see that here, we see it here, and we see it here. Right, that is all of those. Those are the, again, this is the spatial weights matrix. Oops, not maxtrix. Matrix for I and J. Again, right, it's going to be a 1 if I and J are neighbors, and it's going to be a 0 if they're not. This this is Z sub J here, right? This is the data value for the target polygon. Sorry, not target polygon, for the jth neighbor, for the jth neighbor, I'm running out of colors here, right? This Z, right? Again, this is the average of the data set. So we see something in this one that we didn't see in the other one, and that's these ends right here, right? These ends, these are the number of elements, or the number of polygons. And then we also see one other thing that's kind of new here. Let's see if pink shows up okay. And it's this right here. This is the standard deviation. This is the standard deviation of the data set. Okay, so I know I've kind of scribbled all over this, so if you weren't able to get the equation written down, go back to the beginning before we scribbled on it and make a copy of it. But again, basically what we're doing is this top part looks just like the part from the Moran's eye. We're basically dividing it by this complex thing that is essentially the standard deviation of the data set and something that is kind of equivalent to the standard deviation of the spatial weights matrix. Okay, so hopefully this equation makes sense. You don't necessarily need to know exactly what's going on, but you get an idea for what things are going into it and where those things are occurring, whether they're on the top, at the bottom, or both. Okay, so hopefully this makes sense. If you have any questions, please reach out. Thank you.